Okay, today we're going to talk about circle sectors, and the vocabulary words associated with this is the word sector. Sector means a part of a whole circle. It's like a pizza slice or a slice of pie. It's just a little part, or big sometimes, part of a whole circle. An arc length is the sector part of the circumference. Recall that circumference means around. So the sector arc length here would be this little area represented by that sector. A central angle is an angle formed by the center of the circle, and it creates the sector. So the central angle here would be this angle measurement. If I had another circle, and I had this sector, wait, that doesn't work. You need to be a part of the radius. And this sector, my central angle would be 90 degrees. Okay, so sometimes we're going to be asked to find central angles. When we find central angles, what we want to do is create a proportion. The proportion that we are always going to be working with today, we're going to be doing part is to whole as part is to whole. And central angles are part of the 360 degrees of the whole circle. So I'm always looking, what's the parts that I know and what are the wholes that I know? Looking at these first two examples, I want to find the central angle formed by the following percentages of the circles. And if I have 35% of the whole circle, again, I'm just going to make my little proportion skeleton, and the part that I'm given is 35% is to the whole 100%, as I don't know what the central angle is to the whole angle. There's a total of 360 degrees. Now in my calculator, I'm just typing in that x is equal to 360 times 35 divided by 100. And that gives us 126 degrees. So our central angle is 126 degrees. Looking at the next example, if I'm 70% of the circle, well, my part is 70, out of my whole is 100. My central angle degree is my x, I don't know. My whole degrees are 360. So x would equal 360 times 70 divided by 100. Punching that into my calculator, I get 252 degrees. So my central angle is 252 degrees. So that's the way to find a central angle. Again, to recap, what I did was found out the percentage. And I want to do part is to whole as part is to whole. If I'm given percentage, percentage is a part of 100, so I created that proportion. My central angle is part of my total degree measure of 360. Okay, the next concept we're going to have to learn is finding areas of sectors. Again, we're going to do that part is to whole. Okay, so again, we're doing the part is to whole as part is to whole. In my whole circle, the area of a whole circle is pi r squared. That's a formula you're going to want to know. So here's my generic formula for finding area of sectors. I have my area of the sector is equal to the area of my whole circle, as my central angle is to 360 total degrees. So area of a sector is a part. The area of the whole circle is my whole. Central angle is a part of my total degrees. so this is a part, as 360 degrees is the total degrees. It's our whole degree measurement in a circle. We're going to do a couple examples with that. If I want to find the area of the following sectors, again, keeping in mind that I'm working with part is to whole, as my part is to my whole. Another way to write it would be the area, my sector area is to my total, as my central angle is to 360. So sector area, that's what we're looking for on this first one. We don't know. So I say x is to, what's the total area? Well, again, the total area of a circle is pi r squared. So I take this and I go 4 squared, and then I'm going to times it by pi. As my central angle looks like it's 45 degrees, is to the 360. Now I'm going to square my 4, that's 16, and I get, going down here, I get x is to 16 pi, as 45 is to 360. In my calculator now, I'm writing x is equal to 16 times pi, use 3.14, times 45, and then divide it by 360, utilizing the cross product. So I'm just typing in 16 times 3.14 times 45 divided by 35, and I get 64.6, I'm going to round it to. So the area of my sector, that means that if I were to fill this up, this area, my value is 64.6 units squared. I'm not given my units. The next example, take a look. Try to identify what is your central angle, what is your radius. All right, this little bitty circle here we're going to work with. We want to identify what is our radius and what is our central angle. That's the numbers we need in order to make our proportion. So radius, we're given the diameter. The diameter here is 2. Radius is half of the diameter, so our radius is equal to 1. Our central angle, again, we are talking about half a circle. Well, a total circle is 360 degrees, so our half of it would be 180 degrees. Create our proportion. Again, our generic proportion, we would have the sector area is to our whole area, as our central angle is to our whole, or 360 degrees. Doing the part is to whole as part is to whole. Okay, so my sector area, I don't know, that's x. I'm always going to define that as x. Is to the whole area of that circle is pi r squared. Now I'm just going to do some substituting here. R is 1. 1 squared means 1 times 1, so 1 squared is 1. That same pi times 1 is just pi. So x over pi is equal to our central angle over 360, the whole. So our x would equal 180 times pi, call it 3.14, divided by 360. Punching that into my calculator. 180 times 3.14 divided by 360 is 1.57. That is saying the area of my sector, what I am coloring in right now in red, is equal to 1.57 units squared. All right, we're going to do this big old circle here. I want you to take a minute and try to set up the proportion. Okay, keeping in mind, what do I need? Eyes on the prize here. I need to know my radius. What else do I need? I need to know my central angle. Okay. Looking at this circle, try to identify what's your radius. See if I'm outlining what you're noticing. Your radius should be 8. Central angle, try to identify your central angle. See if I am noticing the same. Your central angle is the angle formed by the sector, which is 30 degrees. Okay, now we get to the hard part, the creating the proportion. So again, I'm just going to write part is to whole as part is to whole. And I'm going to do that more often than not because this way to represent a proportion will work in almost all cases. So I like to just represent it like part is to whole as part is to whole. Okay, so again, what's my goal? I need an area. And what do I know? I know a degree. So those are two relationships I can form. So my sector area, which I don't know, I'm going to call x, is to my whole area. The whole area of my circle is pi r squared as, and then I'm given degrees. My central angle is to 360. Now r here is 8, so I'm going to plug 8 in here. 8 squared means 8 times 8, that's 64. So I'm just going to erase this and write 64. So my x is equal to 30 times 64 times 3.14 divided by 360. Plugging that into my calculator, I get 30 times 64 times 3.14 divided by 360 is 16.75. I'm going to round it to. When you're not specified, I usually round to the nearest hundred. So my area of the sector, that means right here, if I were to fill this up with crayon or paint or pizza sauce, whatever you want, the area of it would be 16.75 units squared. Next concept, we're going to talk about arc lengths. Arc length is another part is to whole as part is to whole. Okay, so you're always asking yourself, what am I given? What am I looking for? So arc length, we have a central angle, that's a part, is to 360, that's a whole. As arc length, now keep in mind, arc length is all of these that I'm outlining in red. It's a part of a circumference. So arc length is a part, and 2 pi r, well that's the circumference of a whole circle. The circumference of a circle is 2 pi r. So I can find my arc length given my central angle and my radius. Okay, so if I wanted to find this arc length here, I would say that my central angle is 90. 90 is to my whole degree measure as my arc length, I'm going to call it AL, is to, now if I want to do the whole circle, then the whole circle is 2 pi r. Notice what I have my r is 4. So this is going to be 2 times pi times 4. 2 times 4 is 8, so I can turn that into 8 pi. Finding my arc length then, I get 90, I'm just going to call it x. We're going to just call that x. 90 times 8 times 3.14 divided by 360. 90 times 8 times 3.14 divided by 360 is 6.28. Now let's try to recap. What does this 6.28 mean? It means our arc length, this little bit, is 6.218. Okay, the next one, I want you to try to set up the proportion for it.